Hello students. In this video we're going to continue on with acid nomenclature, and the purpose of this video is to give you just a few more opportunities to practice. So here I have 4 acid formulas and I'm asking you to write their names, and down here I'm giving you 4 names of acids and I'm asking you to write the formulas. So as this is a practice opportunity, I'm going to let you try all 8 of these first, and then after you're finished with them, then I'm going to come along and give you the answers. So you can consider this a sort of practice quiz for acid naming. If you want to, feel free to refer back to the acid naming rules. We have Rule 1 for IDE anions, for Rule 2 for ITE anions, and Rule 3 for ATE anions. So give all 8 of these a try, and when you're done with all 8 of them, then resume the video, and I am going to work through each of them so you can see the process and the answers. So go ahead and pause the video now and do your best to work through all 8 of them, and then resume the video when you're finished. Okay, returning to these practice problems, we first have these 4 with the formulas, and we're being asked for the names. And there's a hint there that reminds you that acids are named based on the anion name. So as I approach this first one, I always ask my primary question, which is, what category does this belong to? A, is it acid? B, is it ionic? Or C, is it covalent? And we see that it has hydrogen in the first position and it's aqueous. And of course all of these are going to be acids because this is a practice sheet for acids. But we want to get in the habit of asking that question so that we can identify it when we're not already told that it's an acid. So yes, this is an acid. I know that acids are named based on the anion name. So I need to isolate the anion first from the hydrogen and then determine what its name is. By removing a single initial hydrogen, then I am left with the anion formula that looks like this, with a single negative charge. And you may recall that this is one of the alternate ways of writing the formula for the acetate anion. This acetate anion ends in ATE, so we are going to use our Rule 3. For ATE anions, we have the root word for the anion and the suffix IC with the word acid. So the root word for this anion, we take away the last 3 letters and it's ACET, acete. And then we add IC as the suffix. So it's acetic acid, which by the way is the acid that is in vinegar. Moving on to the next one, A, is this an acid? Yes, it is an acid, so I use the acid naming rules. I need to know the name for the anion. So let's isolate the formula for the anion. I remove the 2 hydrogens. Each hydrogen takes a positive charge with it, leaving me with 2 negative charges on that anion. And this polyatomic anion is our carbonate anion. It ends in ATE, so again I'm going to use my Rule 3 for ATE anions, and so it's going to be the root word for the acid with an IC suffix. The root word for the acid is carbon, and therefore it's carbonic acid. Next one, is this an acid? Yes, it is. So I need to know the name of the anion. Remove the hydrogen and take its positive charge away, and I'm left with that anion. The name of this anion is nitrite. It is 1 oxygen less than the nitrate. The ending is ITE. So this is an example of the Rule 2 acids, the acids that are based on anions that end in ITE. And so the name of the acid is the root word for the anion plus OUS as the ending. The root word for the anion is NITR, niter, and then an OUS ending. So this is nitrous acid. Next one, is this an acid? Yes, it is. What is the formula for the anion? PO3, and I've removed 3 hydrogens, so I'm left with 3 negatives. What is the name of this anion? This is 1 oxygen less than phosphate, so this must be phosphite. This is an ITE ending, and so I use Rule 2, which is I use the root word with an OUS ending. Notice this is a phosphorus-containing anion, though. What is the root word when it's phosphorus-containing? I don't just stop there. Remember, the root word for phosphorus-containing anions is phosphor. It has 2 syllables. So there's the root word, phosphor. So here's the root word, phosphor, and then I need an OUS ending. So this is phosphorus acid. Now I want to take a moment here and compare this word, phosphorus, with the name for the element phosphorus. The element name ends in RUS. The acid name ends in ROUS, so there's a difference there. So why do we have a difference? Well, linguistically, the US ending indicates that this is a noun. This is phosphorus. The OUS ending indicates that this is an adjective describing the acid. So what kind of acid is it? It's a phosphorus acid. But this is a noun, phosphorus. There's a similarity in some words that you're already familiar with. The words mucus and mucus. Mucus is a noun, and mucus is an adjective. So you can talk about the mucus in your nose, or you can talk about the mucus lining, where mucus, OUS ending, is the adjective. So that's why we have different endings here. Phosphorus acid. Phosphorus element. Continuing on to exercise B, now we're being asked to work backward. So we have to keep in mind our 3 rules. Rule number 1, we have a hydro prefix with a root word and an ic ending. Rule number 2, we have no hydro prefix. We just begin with the root word and an OUS ending. And rule 3, again, we have no hydro prefix. We just have the anion's root word and an IC ending. So let's take a look and see what we have. Here we have hypochlorous, OUS ending. Notice this is hypo, not hydro. So this hypo is not a Rule 1 situation. We're not talking about a hydro, we're talking about a hypo. So this OUS ending must have been generated because the original ending of this anion was an ITE ending, right? Because OUS endings for acids originated as anions with ITE ending. So what was the anion that this started out as? This started out as the hypochlorite. Anion, which became a hypochlorous acid. What is the formula for hypochlorite? ClO with a minus charge. Hypochlorite is one oxygen below the chlorite, which is ClO2 with a minus charge. And chlorite would be one oxygen less than the chlorate, which is the ClO3 with a minus charge. So there is the anion upon which this acid is based. Now that we have the anion, we are going to add enough hydrogens to offset that charge. Since it's a -1 charge, I need one hydrogen. So one hydrogen, then the anion formula. And of course, in this class, we always want the aqueous state indicator. Okay? So there is the formula for hypochlorous acid. Now with that example, you may want to take a moment and go back and take a look at these, because now you may have a better model or pattern for how to solve these problems. Take a look at the name of the acid and determine which rule was used to generate it. Once you have the rule, then you can write the name of the anion and then the formula for the anion, then place enough hydrogens on it to balance the charge, and don't forget the aqueous state indicator. So if you need to take a moment again to work on these three, now that I've given you an example here, go ahead and do that now if you want to pause the video and then come back when you're finished. All right, moving forward, let's take a look at these remaining three. I have no hydro prefix. Since there's no hydro prefix, I know that the anion did not have an IDE ending, because the hydro prefix is only for rule 1 when the anion had an IDE ending. What kind of ending does it have? It just has the IC ending, the IC ending. So it must have originated as a rule 3 case with an anion that ended in ATE. The Ch4 root word must have come from an anion with a phosphorus in it. So what is the anion with a phosphorus in it and an ATE ending? It must be the phosphate. Now that we know the name of the anion, let's write its formula. Now that we have the formula for the anion, let's add enough hydrogens to charge balance. So we're going to need 3 of them. And don't forget the state indicator. Phosphoric acid, H3PO4 aqueous. For the next one, we notice that we have a hydro prefix. That hydro prefix only occurs when we have a rule 1 acid that originated from an IDE anion. So the original name for the anion must have been bromide. So bromide is the monoatomic bromide anion. How many hydrogens do we need to add to charge balance that? Only 1. And don't forget the state indicator. Hydrobromic acid. And the last one, chromic acid. There is no hydro prefix. There is no OUS ending. There's just an IC ending, IC ending. So this is a rule 3 acid. The rule 3 acid came from an ATE anion. And so we have the root word for the anion and an IC ending. The original anion must have had an ATE ending. So there's the root word, and it must have had an ATE ending. So that was the original anion upon which this acid is based. Chromate, CrO4 with 2- charge. I need to add 2 hydrogens to charge balance that. And don't forget the state indicator. Okay, and those are the formulas for those acids. So when you're given the name and you need to work backward, look at the name and determine which rule, 1, 2, or 3, was used to generate the name. Then write the name of the anion that must have been used to generate that acid name. Then write the formula for the anion. Then add enough hydrogens to charge balance the charge on the anion, and then add the aqueous state indicator. So there are some examples for acid nomenclature. When you're given the formula, you can write the name, and when you're given the name, you can write the formulas.